Okay, let's give you guys some examples. So let me ask you this question. So will this area here from 1 to infinity, from 1 to all the way to infinity, will this area here converge or will it diverge? So to answer this question, we would compare this with e to the power minus x. So this x squared here, we're going to compare it with this x. So if you compare the two, notice that beyond one, this will always be greater than this. The function itself here will always be bigger than this function here. So the graph itself here, this graph here, the blue line, will always be bigger than the red line. Now we've already established that if the area of the big line, if the area underneath the blue line converges, then the area of the lower line will also converge. We've already established this in the previous video. But the point here is that, as it turns out, the integral of this from 1 to infinity of the blue line will converge. Therefore, the integral of this from 1 to infinity of the red line will also converge. Now, because this thing here converge, then this thing here will have no choice but to also converge. And the reason why we know that this thing here will converge is because of this. So basically, to solve this, you really need to compare this with this. So hang on. So looking at this here, remember we are trying to establish if this converges or diverges. So from 1 to infinity, well, this area here will always be less than or equal to this area here. Remember, also from 1 to infinity. The reason why is because we know that this thing here will always be bigger than this thing here. So the area underneath this graph will also be less than or equal to the area of this graph. So now we've done this in the past, but we know that this thing here will converge. We've done it many times in the past, but let's just pretend you don't know it. So to integrate this, so we are going to integrate it from 1 to b, and then allow b to head towards infinity. So integrate it from 1 to b, and then later allow b to head towards infinity. Integrate this, it will then give you this from 1 to b, and then allow b to head towards infinity. So now put this into here, put the b into here, that will then give you this, put the 1 into this x here, then that will then give you this, and then as you allow b to head towards infinity, this is going to head towards 0. So really you're taking away a number that's very, very close to 0. This thing here will head towards 0. So you would just end up with this. So here, this thing here is this thing here, and then you're taking away a tiny bit. Well, if you know you're taking away a tiny bit, then this thing here will then become strictly less than this thing here, because you know that you've got this thing here is actually this thing here, but then you're taking away a tiny bit. The minute you know you're taking away a tiny bit, then this thing here will become strictly less than this thing here. So what we're saying is that the area underneath this thing here, this integral will be strictly less than this. So all that we can conclude is this. All that we can conclude is that this area here is strictly less than this. That's all that we can conclude. We don't know the precise area of this. We just know that the area of this would be strictly less than this. Okay?